Welcome to my course, which is a brief introduction to structural geology. I've been teaching intro structural geology courses at different universities now for more than 30 years, and I haven't taught the course the same way twice. So it's not really a great old big deal that this course is going to be a little bit different this semester, because I'm used to that. Although I'm not used to teaching online, so it'll have some rough edges. There really isn't any geologically useful information conveyed by your looking at me talk to you in a video. So I don't imagine you're going to see my face on videos very much this semester. And that's probably a good thing, because I don't want you to be jealous about how good looking I am. But you will have the opportunity to communicate with me directly every day of the semester, either by email or by calling me or texting me on my mobile phone. My phone number is available to you on the Canvas webpage for this course, or by joining me for an office hour every, I think it's every evening, 7 o'clock, every weekday of the semester. We're also going to get together on Wednesday afternoons to hash out the lab material. Make sure you understand that. So when you get stuck or confused, please contact me. Don't be shy. Don't feel like telling me that you don't understand something is going to adversely affect your grade. Actually, it might well help your grade, because my job is to facilitate your learning, and I can't do that if you don't let me know what you find difficult, what you find confusing, what you need help with. So please let me help you. My contact information is on the course homepage in Canvas, and that also has a link to the main course homepage and syllabus, which I have on my family's web whatever. That was inarticulate, but you'll figure it out. I have been helping the National Science Foundation and various projects supported by the NSF to improve geoscience education for decades. At a meeting not long ago in Washington, D.C., an NSF officer began her presentation by bluntly stating that we know that the lecture method is not a particularly effective way of teaching STEM material in college, or words to that effect. Although I love the performance aspect of lecturing, the human interaction, and being a professor, hearing myself talk, the kind of teaching or learning that depends heavily on lectures from teachers, whether online or in person, is not well suited to our current global situation. In fact, it's not well suited to science teaching. This course is designed around a different methodology called flipped learning. When I need to learn about something new, I absorb information from as many different knowledgeable sources as I can find or afford, including videos and texts available on the web, peer-reviewed journal articles available through Baylor's eLibrary, and relevant books. I often try to find someone who can help me up the learning curve a little bit. And to the extent possible, I engage in some activity in which I use or apply this new information right away before it leaves me. Broadly speaking, that's how we're going to proceed with this course in structural geology. My roles in this course are to organize material for you to learn in a way that seems logical, to use the resources that seem optimal in helping you to absorb particular bits of information, to give you a chance to practice with using the new information, and to evaluate how well you've learned certain basics of structural geology. Another imperative that I feel deeply about is the need to take care not to waste your time or overload you with work. Time is not elastic, and our personal supplies of energy are not infinite. I know that you are taking other courses on completely different topics as we learn about structural geology. You should also be sensitive to the fact that a 63-year-old professor teaching 2 different laboratory science courses online at the same time faces a significant challenge to find the time and energy to teach well between now and Thanksgiving. and this teaching gig is not the only thing I have committed to do this fall. We might not be in exactly the same boat, but we're both navigating some challenging waters. Structural geology is a very broad subfield of the geosciences, involved with the processes and products of the natural deformation of rock materials. As a student at the Center for Tectonophysics at Texas A&M University in the mid-1980s, I took graduate courses concerned with structural fieldwork, remote sensing of structures from aircraft and satellites, mechanics of materials, experimental deformation of rocks, physical and numerical modeling of structures, structural geology related to petroleum exploration and production, structural petrology, microstructural analysis, faulting, folding, active faulting and earthquakes, and probably others I can no longer remember. These days, my work is trying to find active seismogenic faults, and that depends heavily on GPS geodesy and high-resolution elevation maps made with aerial LiDAR, technologies that did not exist when I was an undergraduate geology student, or, for that matter, a new faculty member. Learning how to learn is what helped me to grow, along with my sciences, from a solid base of older information. My only reason for taking this stroll down memory lane is to emphasize that this course in structural geology is just an introduction to a very vast field of inquiry. It's a bit like spending an hour or two looking through the visitor center without actually getting out and hiking the trails at Yellowstone or the Grand Canyon. But we have to start somewhere in learning about structural geology, so let's begin learning about structural geology here together. Each week, there will be an assignment that will involve reading, doing lab exercises, and perhaps viewing some online videos. You'll be asked to learn the definitions of terms that geoscientists use to describe the processes and products of rock deformation, and you'll be required to learn how to pronounce those specialized terms correctly. There will be some mathematics as well. You have access to student editions of Mathematica, MATLAB, and Microsoft Excel, so we'll use these apps to help with the computational aspects of our work. Now, I'm aware that students in this class have a wide range of backgrounds and mathematical skill sets, so let's just say that it's my job to help you up the learning curve from wherever you're starting the journey, and it's your job to try your best to learn. So welcome to my course. And let's get on with our good nerdy fun.